So half-life formula. Well, it's another formula that unfortunately you have to memorize. Alright, this is the last video for skill 8.9. All A, B, and C should be on the same day. So, here's the half-life formula. Whenever you see a problem that's talking about a half-life, the rate is going to be 1/2. Okay? You have your T, which is your time. Your P is your starting amount. And again, your N. The N is your half-life, however long it takes for half of it to remain. So it's a pretty simple formula, plugging it in. It has shown up on the Regents a few times, so it's kind of a must-know. Alright, so we'll copy the formula down and read the problem. So we got titanium-44. It's a radioactive isotope such that every 63 years its mass decreases by half. So there you go. Here's the clue. Mass is decreasing by half. That means the rate, right, that we're going to be dealing with is a half. It's a half-life problem. And it happens every 63 years. So that means your N is going to be 63, your half-life. So what are we starting out with? According to the problem, we start off with 100 grams. And we're going to see T over 63. Now again, that can be written in function notation if you want. It's not the end of the world if you don't, unless of course it says write it in function notation, and then apparently it is. Okay, so defining the variables, alright? So N is 63, that is your half-life. Defining all variables. And then we have P is your principal amount, so it's 100 initial. Initial amount, and A is your final amount. And T is the time in years. Okay, and that's that. Let's move on to, I think, the last one. So here we have again another radioactive isotope. Right? Isotope has a half-life of 29 hours. For a sample of 250 grams of the isotope, write a function that would be used to determine the remaining mass for any amount of time. So, again, we have the half-life is 29 hours. So again, when they say that, your rate is a half. You're going to write the half-life formula. So A equals B times 1/2 to the T over N. So A equals principal amount, which it says right here, there's your P, there's your N, is 250 times, I typically like to use 0.5, it's just much easier than using half, but it doesn't matter. And then you have T over N, which is 29. So if they say how long would it take, right, in a typical Regents question, I'm sorry to add on to this, but a typical Regents question isn't going to say write the formula, it's going to say how much time until we have 100 grams left? Well, if you see a question like that, you're going to first have to A, write this equation, and then figure out how long it will take to just have 100 grams. So you'd have to plug in 100. Divide 100 by 250. And then you're going to have to log it, or change it to log form, I'm sorry. So the 100 divided by the 250 is going to give us 4/10 equals 0.5 of the T over 29, and then we would change it. I'll just change it and then we'll stop there. We won't actually solve it. So you'd have the log, base stays the base, which is not that. We can't write today. Log of 0.5 of log base 0.5 of 0.4 equals the exponent T over 29. The base stays the base. So you type that in, and then at the end of this problem you'd have to cross multiply. It'd be kind of nasty, but multiply both sides by 29. Alright, so don't forget to rate your summary and get your practice done.